Okay, so now before doing some problems related to differential equations, I want to explain to you another concept of transfer function. Okay, this to understand do the problems on differential equations for Laplace transform, it is very important that you understand that there is another meaning of h of s. Okay, and in order to find the value of h of s, you have to apply this particular concept that I am going to explain to you today. Okay, this concept is very important, and it's very important that you should try to understand it. Okay, so what I'm trying to tell you is that we all know that the equation for the output of any LTI system, right? The output for any LTI system is given by y of t is equal to x of t convolution with h of t, right? This is how we define the output of an LTI system, right? That is where y of t is the output of that system, x of t is the input, and h of t is the impulse response. Is the impulse response. Okay? And likewise, when I take the Laplace transform of this equation, okay, the Laplace transform, then this convolution becomes a multiplication in the frequency domain. So I will get y of s is equal to x of s into h of s, right? Where y of s is the Laplace transform of y of t, x of s is the Laplace transform of x of t, and h of s is the Laplace transform of h of t, right? Or in other words, in order to find my h of s, I can say that h of s is equal to y of s, that is the output Laplace transform divided by input Laplace transform. So this is how we define our transfer function, okay? But you need to understand the meaning behind this equation, y of s by x of s, okay? It does not simply mean that you have to simply divide the output Laplace transform input Laplace transform. It does not mean just like that. You have to understand what this actually means, okay? See, because the reason is, this h of s is what you all know that this h of s is what you call as the transfer function, okay? And so as I said before, the transfer function is nothing but the Laplace transform of h of t. So that means the transfer function is the Laplace transform of the impulse response, right? The transfer function is the Laplace transform of impulse response. So what is the meaning of impulse response? Impulse response. Look at the words. Impulse response. I have already said last class that response means y of t. Response means y of t. So I can say that this h of t is nothing but the impulse response, or response of the system when the input is an impulse signal, right? That is, h of t is the response of the system when the input is the impulse signal del of t. Or in other words, I can say that h of t is equal to y of t when x of t is equal to del of t, right? This is how we actually define the impulse response. That is, it is the output of the circuit or output of the system where the input is a del of t. That is, if you want to find the impulse response of any system, you just give a small impulse signal to the input. A small impulse signal to the input, and you see how the system reacts. And that's how we find the value of h of t. Okay, that is, it's nothing but the value of the y of t when you substitute x of t as del of t. Okay, so one thing you already know is that the Laplace transform of del of t is actually equal to 1. The Laplace transform of del of t is actually equal to 1. So in other words, if I substitute del of t as x of t, then I can say that the Laplace transform of x of s will also become 1. Right? Because x of t is equal to del of t. If x of t is equal to del of t, then x of s is equal to 1. And if x of s is equal to 1, then I can say that what is h of s? my transfer function. It is nothing but my output response. My output response when x of s is equal to 1. This is what you need to understand regarding the transfer function. That is, the other definition of transfer function is that it is nothing but your output response when the input response is unity. And why is the input response unity? Because the Laplace transform of the input signal is, which is an impulse signal. So Laplace transform of the impulse signal is 1. You see, so because your input signal is an impulse signal, you can find your impulse response. And likewise, because the Laplace transform of the impulse signal is 1, so you can find my response or my transfer function h of s, which is nothing but y of s. See, so this is how we understand the relationship between h of s and h of t. Okay, so what is the significance of this h of s? So the reason why we are applying this is that because there is another thing that you need to learn, and that is another concept that you need to understand, and that is called as the initial conditions. Initial conditions. So what are these initial conditions? These initial conditions are the state of that system when you are not applying any input to it. You see, without applying any input, the state is naturally in that response, it's naturally in that particular system, it's naturally in that particular condition. Okay, so in that case that condition is what you apply is the initial condition. That is, we don't apply any input to the system and still you get an output. And why you get the output? Due to the presence of the initial conditions. Now, where does this initial conditions come from? Where does this thing come from? We all know that when you are going to apply the Laplace transform to any differential equations, for example, if I write the Laplace transform of dy of t by dt, we all know what is the Laplace transform of this, right? This is nothing but s y of s minus y, or small letter y of 0 minus. This y of 0 minus is nothing but y of t at time t is equal to 0, right? And also, there's another equation, that is, this is a first degree differential. If I apply second degree differential, then this Laplace transform of d square y of t by dt square. This is nothing but s square y of s minus s into y of 0 minus y dash of 0 minus. Y dash of 0 minus means dy of 0 by dt. That is meaning of y dash of 0 minus. You see, so these red colored terms is what you call as the initial conditions. So this is where the initial conditions enter into the system, right? So that means, in other words, the meaning of this equation is that the output of a system is not only due to the input, but it is also due to the initial conditions. It's also due to the initial conditions. And when you want to find your transfer function of that system, then you should always apply your initial conditions equal to 0. No matter what value they give you in the question, in order to find your h of s, the transfer function, you have to make sure that your initial conditions are all 0. That is how we calculate the transfer function. Okay, just to make you an example, let me just make you do a small simple problem to make you understand the significance of the transfer function as well as the initial conditions. Okay, see, because the reason why we are doing this is because the total response of the system, that is your y of t, you see, y of t consists of two things. It is the output of the circuit is mainly because of two factors. One is because of the initial conditions, That is the conditions that is already been existing before you give the input. That is the meaning of these initial conditions. So your y of t, the response of the signal y of t, its effect comes from, one effect is because of the initial conditions, and the other effect is because of your input, that is x of t, right? So this is how, so the combined effect of these two is what gives your output response. Or in other words, adding these two response, I could say this is called as the total response. The total response of the system. Yes, this total response is given by the response due to the initial conditions, which is also called as the natural response. It's also called as the natural response, or also called as the free response. Free response plus, so this is what you call as the natural response or free response. That is response of the system only due to the initial conditions. Okay, so your total response is made up of your natural response or free response, plus it is also consists of your forced response. Also called as your zero state response. That is the response of the system due to the input alone. Due to the input alone. These two are independent of each other. This is only due to the initial conditions, and this is only due to the input signal. Right? This is only due to the initial conditions, and this is only due to x of s. So which means your transfer function that you are going to find contributes only to the forced response. See, so that is where this h of s comes from. That is why when you are going to find the value of h of s, we always put the initial conditions to 0. Right? We always put the initial conditions to 0. So in that case, then why are we using initial conditions? Like I said before, you are using the initial conditions only to find the value of y of t, your total response. So to find the total response, you have to apply the response due to your initial conditions and your response due to your transfer function and the input signal. Okay, if you want to find the value of a transfer function, simply put your initial conditions to 0. That is how we define your transfer conditions, transfer functions. Okay, let's take one small example just to make you understand all this what you have learned so far. Okay, so one example I could say is that suppose there is one equation. Let me write that equation. That is let me say that d square y of t by dt square plus 3 dy of t by dt plus 2y of t is equal to x of t. Okay, so this is one differential equations. Now from this differential equation, I want to find my h of s. I want to find my h of s, and I want to find my h of t, which is nothing but your impulse response of, it is nothing but the Laplace inverse of h of s. And now after this, I want to find the value of y of t. Okay, I want to find the value of y of t. Now what is this y of t? This y of t is the output response of this system. The output response of this system. Okay. So I want to find this, I want to find this, and I want to find this. Okay, and let me also assume that the initial conditions is given by y of 0 minus is equal to 1, and dy of 0 minus by dt is also equal to 1. Okay, or this can also be written as y dash of 0 minus. Okay, in the exam they'll either give you like in this format or they'll give you in this format. Both are same, y dash of 0 minus. It's better that you learn to write y dash of 0 minus. So it will be very easy to write your steps. So in that case, how do you find the h of s? Okay, so the first thing what I do is I apply my frequency differentiation theorem to this differential equation. Okay, so that means if I apply Laplace transform to this equation, I get, first let me apply it over here, d square y of t by dt square is nothing but s square y of s minus s y dash of 0 minus, not y dash, y of 0 minus y dash of 0. Okay, so this is my equation, plus now the differentiation of this is, the Laplace of this is 3 into s y of s minus y of 0, okay, plus 2 y of s is equal to x of s. You see, so this is the Laplace transform of your differential equation. Okay, this is the Laplace transform of the first term, this is the Laplace transform of the second term, this is the Laplace transform of the third term, and this is the Laplace transform of x of t. Okay, so now if you want to find the h of s, if you want to find the h of s, what I'm going to do is I'm going to make every initial conditions in this equation equal to 0. Even though the question they have given the value of the initial conditions, to find the transfer function, I'm going to make every initial conditions equal to 0. That means this is equal to 0, this is equal to 0, this is equal to 0. So what do I get? I get s square y of s plus 3s y of s plus 2y of s equal to x of s. Or in other words, this is nothing but taking y of s common, it becomes y of s into s square plus 3s plus 2 is equal to x of s. Or in other words, your h of s, the transfer function h of s, is nothing but y of s by x of s, y of s by x of s, which is nothing but 1 by s square plus 3s plus 2. You see, this is how we find the transfer function, that is the output of the system due to the input alone. And here x of s is equal to 1. You can see, if I substitute x of s is equal to 1, okay, so then if I substitute x of s is equal to 1, then y of s will become h of s. You see, that's how it becomes h of s. And this h of s is equal to 1 by s square plus 3s plus 2. Or this is also equal to 1 by 2 plus 1 is equal to 3, and 2 into 1 is 2. So that means I can write this as s plus 2 into s plus 1. I can factorize this as s plus 2 into s plus 1. You see, so this is how I define my transfer function. That is this one, your h of s. This is how we define it. Okay, so now to find h of t, I think you already know how to find h of t, right? H of t you can already find by using the format, that is Laplace inverse of h of s. It's a Laplace inverse of h of s. That means I can say that h of s, you can find the value of h of s. You can find the value of h of s by applying partial fraction, that is a by s plus 1 plus b by s plus 2. Okay, then here you will get a as 1 and b as minus 1. So you will get 1 by s plus 1 minus 1 by s plus 2. Okay, this is your h of s. Or in other words, your h of t is nothing but your Laplace inverse of this, that is e raised to minus t u of t minus e raised to minus 2t u of t. So you found an impulse response. Okay, so you found an impulse response, you found your h of s, and these two functions, that is your h of s and h of t, for these two functions, your h of s and h of t, for these two functions you found out only by making your initial conditions equal to 0. All your initial conditions equal to 0. Okay, so now Now I'm going to find my y of t. Okay, so let me remind you, the Laplace transform of this y of t is not this y of s, because this y of s is taken under the condition that there is no initial conditions. Okay, but when you are going to find the actual response of y of t, it is not only due to the transfer functions, but it is also due to your initial conditions. That means so far you only found this, the transfer function of this. Now you're going to find this, which means that this time you are going to apply your initial conditions. And here in the given question, the initial conditions are y of 0 minus is equal to 1 and y dash of 0 minus is equal to 1. So now you're going to apply these two initial conditions. So what happens if I apply those two conditions now? How does my equation look like? Then my equation will become s square y of s minus s y of 0 minus y dash of 0 plus 3 into s y of s minus y of 0 plus 2 y of s. Y of s is equal to x of s, right? So that means that if I now substitute my suppose if I substitute my y of s, my y dash of 0 and this y of 0 is 1, so I will get over here as s square y of s minus s minus 1 plus 3 into s into y of s minus 1 plus 2 y of s is equal to x of s, right? So now I'm going to group all the y of s terms together. So this will become y of s into s square plus 3s plus 2. Okay, and then the remaining terms, what are those remaining terms? It is minus s minus 1 and minus 3, right? Am I correct? Minus s minus 1 and minus 3 is equal to x of s. Okay, so this minus s minus 1, I can write this as, if I'm bringing this over here, this will become y of s into s square plus 3s plus 2, and this is equal to, this will become s, becomes plus 4 plus x of s, right? Or in other words, y of s is equal to s plus 4 by s square plus 3s plus 2 plus x of s by s square plus 3s plus 2. You see, you have already seen what this is. This is what you call as your h of s. You see, 1 by s square plus 3s plus 2, your h of s. 1 by 3s square plus 3s plus 2, right? Or that means if I put x of s here, it will become x of s by s square plus 3s plus 2, and that is exactly what you are seeing here. That is, here this is what you call as your forced response or zero state response. This is what you call as your forced response. Your forced response. If I substitute x of s is equal to 1, because unit impulse signal, the Laplace transform of impulse signal is 1, so f is 1, so the x of s also becomes 1. So this will become 1 by s square plus 3s plus 2. So that is why this is nothing but your transfer function, right? That is called as your forced response, or also called as your zero state response. Okay, and this, the first term that you are seeing right now, that is being introduced due to the initial conditions. This is what you call as your natural response. You see, so that is how we distinguish forced response and natural response. That is, this is only due to the input signal, and this is only due to your initial conditions. Okay, so which means that if you want to find your transfer function, that is this forced response, then it is necessary that you put all the initial conditions equal to 0. Okay, so that means the only time you are actually applying this initial conditions is when you are trying to find this y of t. Is when you are trying to find this y of t. That is the only reason you are going to apply your initial conditions. Okay, so this is the concept of transfer functions that I want to tell you. Okay, so now let's make this concept more stronger in your minds by doing some more problems. Okay.